Welcome to qnawire.
Part A of this problem, we need to find the coefficient of friction such that the velocity of the system is constant. This means that the acceleration is equal to 0. Now, to find this quantity, we need to first draw all the forces acting on these two boxes or blocks. So putting the axis, we draw all the forces. So in block A, the forces acting are the normal force perpendicular to the surface, the weight of the block A, the tension of the rope that we call T, and the coefficient of friction that opposes the motion of this block, and we call Fr. For the other boss or block, we have that the only forces acting on this are the tension, that is the same tension because the rope is the same, and the weight of the block B, that we call weight B. Now, applying Newton's second law, we sum all the forces. So the forces in the Y part for the block A are the normal force minus the weight of A. This equals to 0 because the block is not moving in this component. And for the X component, we have the tension, which is positive because we set this part to be positive, minus the friction force. And this is also equal to 0 because we want for the condition when the velocity is constant. And when the velocity is constant, we note that the acceleration is 0. So we need to set this to 0. For the block B, we have only that it is moving in the Y component, so we just sum the forces in that component. That will be the tension minus the weight. And because it is also moving with a constant speed, it has 0 acceleration. From this, we obtain, from the first one in here, we obtain that the friction is equal to the tension. And we know the definition of the force of friction is the normal force times the coefficient of friction is equal to this is equal to the tension. And from this, that we are calling 1, we are calling 2, and we are calling 3. So from 1, we obtain that the normal force, we just pass this to the right-hand side. We obtain that this is equal to the weight of block A. Now, substituting this into this equation, we obtain that the weight A times the coefficient of friction is equal to the tension. And from here, we obtain that the coefficient of friction should be equal to the tension over the weight A. Now, from this third equation, we know that the tension is equal to the weight of block B. So using this and this equation, the equation that we found for the coefficient of friction, we find that the coefficient of friction is simply the ratio between the weight of the block B and the weight of the block A. We know that the weight is defined as the mass of the block times the acceleration of gravity. So we have this, we can cancel the acceleration of gravity and we'll obtain mv over ma. Putting the values that we know for this problem, is that MB is 25 kilograms and MA is 45 kilograms. So the coefficient of friction is equal to 0.56. Part B of this problem tells us that now a cat that weighs 45 newtons fall asleep on top of the block A. And then now the block B is set into downward motion. And we are asked what is the acceleration in this new configuration. So we have the same in here, block A attached to block B. But now we have a cat that is sleeping in here. We're just gonna trying to draw a cat, something like this. Something like this. Suppose this is a cat. Well, now the force, the mass of MA will be, we're gonna call all of this MA. So it will be the mass of the cat and the mass of the block. We know that they just have the same mass, so it will be 2 times 45 newtons, which is 90 newtons. And for the mass B, we have the same as before. So we found that the coefficient of friction is 0.56. And then we need to find the acceleration of the system. Now, in this case, I'm not going to draw again the diagram of forces because it is essentially the same. Now, the only thing that is changing is that we have an acceleration for the system for the two blocks, and that the mass of the block of A changes. So that's the only thing that changes. So for mass A, we have that in the y component is the normal force minus the weight of A. In this case, it is not moving um, in the y component. And for the x component, we have a tension that we set as positive minus the friction force. We're going to simply put it as how it is defined. So the friction force is the normal force. From this, we can obtain that from the first one, we obtain that in normal force is equal to the weight of A. So we know that the friction force is equal to the normal force times the coefficient of friction. So the normal force is equal to the weight, so it should be the weight times the coefficient of friction. And this, because now the system is moving with acceleration, this is equal to mi times the acceleration. Now for mass b, we find that it is only moving in the y component, and so we have the tension minus the weight b, and this is equal to the mass of b times the acceleration. Is the same acceleration because they are attached with the same rope. Now, we have these two equations, this and this. We have two variables that we don't know, t and a, and we have two equations. So this is just a problem to try to solve it by finding the value of t or the value of a, just by rearrange one of them and just substitute it in the second one. We can see that this could be more easily done if we just subtract 1, the equation 1 to equation 2 so that we eliminate the tension and we just need to find the acceleration. So we are going to do that. Subtracting 1 minus 2, we obtain the following. The the tension goes away, so we will find that it is minus the weight of A times the coefficient of friction plus the weight of B, and this is equal to the mass of A minus the mass of B, because we are subtracting equation 1 minus equation 2, and this time the acceleration. So now the acceleration is equal to this difference in weight over the difference between masses. Sorry, here I make a mistake. This is MA. Now, we know that the weight is defined as the mass times the acceleration of gravity. So we're going to put that in there. And the acceleration of gravity, just factor out ma times mu. And this over the rest of the mass, the difference between masses. Now, put in all of these values, we obtain that the acceleration of gravity is 9.8 meters per second squared. The mass of MA, which is the mass of the cat plus the mass of the block, is 90 kilograms. This times the coefficient, which is 0.56, plus the mass of the block B, which is 25 kilograms, and this over 90 kilograms minus 25 kilograms. So putting all of this information into the calculator, we obtain a value of in here. I have something wrong. So because the mass MB is moving downwards, we need to account that for this equation for mass B. So it must be, this mass must be equal to minus MB. So in this sense, when we rest the equation 1 minus equation 2, we are obtaining here plus. So in here is plus the sum of the masses, and it will be in here plus the masses. So now we are going to find that the value for the acceleration is 6.43 meters per second squared. And this value is the correct value because it is less than the acceleration of gravity.